record and computer's on. All right, so it's gonna be test number 6 problems. Test number 6, so it's gonna be net force. Okay, so the way it is you got this train coming to a stop, right? It's gonna be coming to a stop within about 700 feet. It's coming to a stop without skidding, so which means that the static frictional force is the only force acting on it. So the applied friction is going to be 8% of its maximum value, which means that it's going to be 80% of the maximum static frictional force. It says determine the speed of the train just before the engineer engages the brakes. All right, so which means that the train is going to come to a stop without skidding at 80% of its maximum static frictional force. That's what it means. Okay, so the coefficient of static friction between the train and the tracks is going to be, this is misspelled, it's going to be 75%. All right, the first thing I'm going to do is I'm going to do a force diagram, right? So this thing is slowing down. All right, so it's going to be slowing down from what speed we don't know. That's what we're going to be looking at. So it's going to be slowing down to stop within 700 feet. And static frictional force is acting on it. So static frictional force acting on it is going to be 8% of its maximum value. So 0.08 means it's going to be 8% of its maximum value. It's got an initial speed, so it's going to go from initial speed to final speed. So the initial speed is what we were trying to figure out. All right, so the only force acting on it along the direction of motion is going to be the static frictional force. F is going to represent the static frictional force. In the y direction, it's got weight. So the weight is going to be responsible for the normal force. Weight is going to be responsible for the normal force. All right, so we got some conversions. Feet needs to be expressed in terms of meters. So we end up getting that number. And then what I'm going to do, I'm going to go to the formula sheet and just grab the equations which may be related to this problem. Okay, you know, there's a force acting on the train. So anything related to acceleration, I will grab. All right, so those are the equations which will be relevant to this solution. All right, so initial speed is what we're looking for. So what is the initial speed that's going to bring the train to stop within 700 feet? Okay, so that's what we're interested in. All right, so initial speed is what we're looking for. All right, so in terms of the initial speed, this has the initial speed. This is going to be uniform motion because the motion is going to be uniform. This is not the formula I would use. This is for the average acceleration formula, which implies that the acceleration is changing. So because I'm looking for the initial speed, either use this one or the last one. I cannot use this one because time is not given, but the distance is given. So it's the only one that I can use. So that's the one that I will pick. All right, so you have to solve for the initial speed. You know that the final speed is going to be 0. All right, so what I'm going to do is I'm just going to isolate VL. The rest is algebra. Just get rid of the square of the initial speed from both sides. So you just subtract them. Get rid of 2, and then get rid of A. I decided to move things around. All right, so get rid of the minus sign, right? Multiplying both sides by the minus sign. And then take the square root of both sides. That's it. All right, so that's the initial speed. All right, so we know what x is, so it's going to be, what, 700 feet. We don't know what A is, so we need to come up with an expression for A. A is unknown. All right, so here's what I know. The acceleration is going to be caused by an external force. So that's the formula that we have to use. Acceleration is going to be caused by the external force. So just sum up the forces on the x direction. All right, so take a look at the forces on the x direction. There's only one force on the x direction. That's the static frictional force. All right, so it's pointing to the left, so it's opposing the motion. So it's going to be negative. The force on the x direction is going to be the static frictional force. So substitute back into that formula. Solve for A. All right, and then do a back substitution. All right, okay, so notice that you got negative and negative. Negative times negative is going to be positive. All right, so the expression looks like this. So the next question is, are we done? Okay, so mass is not given to us, so obviously that's out of the question. We also know what the static frictional force is. The only thing we got is x. So what we need to do is now we have to come up with an expression for the static frictional force. All right. Oh, we don't have to come up with an expression for the static frictional force. Evidently, we do have the static frictional force. That's going to be 80% of the maximum static frictional force. Okay, cool. So we already got here. I do a back substitution. All right, and all right, so we got 2 times that number. This is going to be 1.6 maximum static frictional force times x. Okay, now, once again, we don't know the mass. We don't know the maximum static frictional force. But we do have an expression for the maximum static frictional force. Guys, the expression for the maximum static frictional force is going to be this. This is going to be sub s times n. Okay, we don't know what n is, but we know how to get n. Is the reaction force in this case to the weight. All right, so because this object is weight, sitting on a surface, it's going to create normal force, apparent weight. So sum up the forces on the y direction. There's no acceleration on the y direction. So which means that n is going to be the same as w. W is the same as mg. Once again, back substitution. All right, and you will have to do a back substitution here. Okay, immediately you notice that the mass is going to cancel, so the mass is not going to matter. End up getting a cancellation of the masses. Mass wasn't given anyway, so it's not a big deal. G sub s is given. You know what g is? It's going to be roughly about 10 We know X, this is about 700 feet in terms of meters, whatever that is. And we also have an expression for mu sub S, which is what is it, 0.75 or something? All right, so you have to look this up. Is this for a train? No, this is not for a train. What is this for? It's going to 1.2. Okay, for a train, it's going to 0.75. Okay, so whatever the number is, just look it up. Okay, so I did it for a car. That's fine. Okay, so if there's a mistake, this would be a mistake. So there would be a very small fraction of a point, which would be deducted. Okay, so you have to look this up. I end up getting the mu sub S for a car. For a train, it's going to be 0.75. All right, so this is going to give you about 140 miles per hour. Okay, it's kind of goofy because it's given to you. The coefficient of static friction is already given to you. I end up using it for a car, but that's fine. Okay, so you guys got the idea. All right, so that's the way it was supposed to be done.